Hey everyone, and welcome to the Retro channel, and today we are doing a video upgrade for the Atari 2600. This has been something I've been working on for many months now, and what it's going to give us is an upgrade from the original RF output to composite and S-video. So these are the little boards that I've designed. Basically what these do is solder underneath the TIARA, which is the video and audio chip in the Atari 2600, and obviously give us the upgraded video outputs. I actually made two different versions, and that is because one is for PAL and one for NTSC. The 2600 uses a different tier depending on the region, and the pinout for them is actually different as well. So it was easier just to design two different boards depending on the actual region, rather than trying to mesh everything into one board and have a bunch of jumpers that you'd then need to set depending on the console region. So I've got three different Ataris here that we're going to install these into. Obviously we've got the original 6 switcher. This is a light 6er, so it's not the OG heavy 6er, but it's close enough. We've also got a 4 switcher, of course, or Vader, and a 2600 Junior. So we'll start off with the 6 switcher, move to the 4 switcher, and then of course to the Junior. This one is NTSC, these two are PAL. So let's open up the 6 switcher first and get one of these installed. So for the 6 switcher, you should find 6 screws on the underside, and of course they need to be removed. There's normally an RF cable hanging out of this corner, but I've already removed that. They basically just unplug from the board. Now it is possible to use this mod to get composite and S-video and still have the RF available if you want to, but I imagine most people that are looking to do this mod aren't too worried about the RF output. Right, with our screws removed, we should now be able to just lift off the bottom cover, just give it a little shake, and that'll give us access to the underside of the main board, and really this is the only place we need to get to. So we need to remove these 6 screws that hold on this little metal can. So with those out of the way, this should just lift off. And now we have access to the underside of the TIARA, which is exactly where this board is going to be soldered. Just make sure that you line up pin 1 with the marking on the silk screen, so you can see it's on this corner. So pin 1 of the TIARA, which is noted by this little square, should sit around pin 1 of the actual TIARA. Now the PAL 6 switcher will look slightly different, but you'll still find the TIARA down towards the bottom of the board, and pin 1 is still going to be on that bottom right corner. There is also another difference between the PAL and NTSC versions, and that is to do with R213, which is only present on certain NTSC 6 switches. In fact, it's not even there at all on the 4 switcher. Well, it is there on a 4 switcher, but it's a totally different resistor, so I'll have to fix up the silk screen with the next batch. But R213 sits between pins 6 and 9 of the TIARA, and it seems like sometime during the production run of the 6 switcher they actually removed this resistor. I guess they realized it was causing more troubles than it solved, and you definitely want to remove that resistor if you're doing this mod. If you leave it in, you're going to have overly saturated colors, and it's not going to look too pretty. So the easy way to check is just to grab a multimeter and measure between pins 6 and 9 of the TIARA. As you can see, this one says open circuit because that resistor is not present. If it reads somewhere around 680 ohms, then that resistor is installed and it needs to be removed. On this 2600, it seems that resistor was never installed. You can see where it goes right here, so you can see this trace coming off pin 9 to this pad here, and off pin 6 to this pad here. So of course, if that resistor is there, you can probably just heat it up from this side and just push one of the legs back through the board. It's probably enough to, take it out of circuit, but always double check with the multimeter afterwards. Now, one other thing to note about the NTSC 2600, there is technically 2 audio outputs from the TIARA, and some people have used this to get a stereo mod from the Atari 2600, but to be honest, I wouldn't really bother with it, and there's not really any provisions on this upgrade board to give you a proper stereo output. If you want to experience what the stereo sound is like from the 2600, definitely download the Stellar emulator and load up your favorite game, and somewhere in the options for Stellar you can actually set the stereo mod. I think Atari originally intended to have 2 speakers inside the 2600 itself. There is one modern 2600 game that does take advantage of that, but in general it just sounds weird in my opinion. The other challenge with doing the stereo mod is the two audio output pins from the TIARA are actually joined together on the board by a little trace. So usually you actually have to desolder the TIARA to cut that trace and then, reinstall it, which could end up damaging your board. So to be honest, I don't really recommend doing it. And when it comes to the PAL version of the 2600, the TIARA on those only outputs one audio channel, so a stereo mod isn't even possible with those. So once you've confirmed this board is lined up correctly, all you need to do is flow a little bit of solder into all of these pins that have a plated through hole. And that's it, the TIARA is now installed. Obviously we still need to connect some outputs so we can actually take advantage of this thing, but we'll come to that in a minute. Let's first install this in the 4-switcher and the Junior, and then we'll go through how to actually utilize these outputs. So on these things, there are only 4 screws to remove. So once again, with our 4 screws removed, you can basically just lift off the bottom cover. And on these ones, you'll probably have an RF shield to fight with. These are pretty simple to take out. In fact, you're probably just better off removing the board from the top case as well. Be sure not to lose these little dust cover stoppy things. Put that aside, and now we can remove this RF shield because obviously our TIARA is hiding under here. So you'll find a bunch of little tabs that basically stick up through the 2 RF shields, and normally they'd be twisted, so you just need to straighten those up, go around and make sure they're all straight. And once you've done that, you should be able to remove both the top and bottom RF shield. That one just fell straight off. Yes, so the TIARA in this one actually has some wonky sound output. The video output looks perfectly fine, so I haven't totally condemned this chip, but yeah, I put that on there as a little reminder to myself. Unfortunately, I don't think there's a modern replacement for the TIARA, so they are somewhat hard to come by. So there's no changes that we need to make to this board. Oh, there's the original RF output, so normally that cable would be plugged in there. Obviously I've already removed it because I don't really plan on using that, but it'll still function even after you install one of these mods, should you ever want to use RF. Anyway, once again, we're going to be installing this on the underside of the TIARA, and pin 1 on these is that corner up there, so the board is going to have to go like so. Same deal, we're just going to flow a little bit of solder into these plated through holes. And we're done. Of course, I can still replace this TIARA because I have actually put it in a socket, but normally on the 2600, a lot of these are not going to be in a socket. So it is possible to remove the TIARA once you've soldered it in place, just either with solder wick or a desoldering gun. They do come off relatively easy, but of course, if you're worried about replacing the TIARA sometime in the future, maybe socket it first before installing one of these things. Cool, so that's the 4-switcher done for now. Once again, we'll talk about how to actually hook up the outputs once we get the Junior finished. And I'm not going to be bothering with these things. All right, the little Junior. I think we've got 5 screws, just to be different. And once you've got those out, there are a few hidden clips that you also need to deal with. If you look carefully through these vent holes, you'll notice that there is a hidden clip on each end. So there's one down here, and if we can see it in the camera, there's one up here. There's also one in the middle. So the easiest way to release these is just to sort of grab the bottom half of the case and with your index finger, gently push up on the top half, and then get a little pry tool in and just release that clip. Once that's done, you can move over to the center clip, and once you get that released, the other clip should just release as well. Now, normally at this point, the bottom case wouldn't just lift off because the board itself is actually clipped into the bottom, but one of the clips is broken on this one. So let's just pretend that that's still clipped to the bottom part of the case. What you normally would do is flip this thing over, open up the top case towards the right, and you'll find this membrane that's plugged into the top of the board that just needs to be pulled out first. And once the top half is out of the way, that's when you'd go for these clips to actually release the board. But yeah, you can see the one on this side is actually broken off some time ago. So putting the case aside, once again we've got RF shields to deal with, both on the top and bottom, and once again, like the 4-switcher, they're just held together by these little twist tabs. So once you've straightened all these up, the bottom shield should lift off, and likewise the top shields should also come off. And once again, this is a PAL machine, so if you see 2 crystals on the board, then it's definitely a PAL model. If there's only 1 crystal, then it's NTSC. But regardless of the region, you will need to make a change to R31. So on the NTSC version, you need to remove R31 on the juniors, and on the PAL version, you actually need to change R31 to 3.3K. R31 is, I think, always in this location right here. So you can see that there's currently, I think that's a 10K resistor. If you don't make those changes, the machine will still work. It just won't look as good as it can with this video upgrade. I'm just going to use a bit of braid to get this one out. So it's that one right there. I think that just fell out. All right, it's just hanging on. There's a tiny bit of solder still holding it. There we go. So if this were an NTSC model, that's all we need to do. But because this is a PAL version, I'm going to put in a 3.3K resistor in its place. Like with all my other stuff, the TIARA will be available on the Electron store. So you'll see an option there to include a 3.3K resistor if you have the PAL Junior boards. Now we can finally install the TIARA. And on the junior boards, pin 1 is on this corner. So once we flip it over, the TIARA is going to go that way. Flow a bit of solder into the plated through holes. And we're done. So now we've got the TIARA installed in all 3 of these machines. Let's talk about the options to get the video and audio signals from here over to our display. Now I'm going to leave this part up to you. I was trying to find an ideal way to, get all these signals out of these various models, but because they're all so different and people might have already modded their 2600 to add composite and audio, there's no one-size-fits-all solution. Some people might have already mounted RCA jacks to the back of their 2600 and drilled holes in the case. Other people who didn't want to particularly drill holes may have added some kind of 3.5mm jack to the underside of their case. I've seen a video on YouTube of some guy doing that. I think his name was Lee or something. Don't know what his deal is. But I'm going to actually go for something a little bit different, and it's going to involve a 5-pin DIN connector. Now, to be honest, I'm not a huge fan of somewhat non-standard connectors, but 5 pins is really all we need, and it's not like I don't have other systems that also use this thing. The VIC-20, which I've also made a video upgrade for, uses a 5-pin DIN, as does the Atari 8-bit computer range. So it's not that unusual to come across one of these, and as long as you keep the pin out the same, you can always, reuse cables between all the different systems. What's also handy is these cables are pretty easy to come by. So this is a 5-pin DIN to 4 RCA connector. And as you can imagine, one of them carries an audio output, one is for chroma, one for luma, and one for composite. These colors also happen to match the colors that you'll find on the back of a Commodore monitor that has these separate chroma luma inputs. You can also take the luma and chroma and get a 2 RCA to S-video adapter, and that'll allow you to use it on displays that have the standard S-video mini DIN. So I'll leave it up to you whether you want to use a 5-pin DIN connector like this, or if you want to have RCA jacks on your 2600, or maybe you already have some installed, or a 3.5mm jack, whatever works for you. But yeah, like I said, there's no really one-size-fits-all solution. But at least with the 5-pin DIN, we only have to drill 1 hole in the case, and it kind of matches the rest of the Atari 8-bit computers. So going back to the 6 switcher, obviously I'm going to put this on the back somewhere. Probably on this side I think would be best. So we just need a few wires to go from here over to here somewhere. So what I'm going to use is this junky RCA cable. You can see it's kind of already falling apart, so I'm not too worried about cutting this thing up. And then we can measure out roughly how much cable we need. Let's say about that much. So I'm just going to cut off 4 pieces of the same length. Well, I got 3 out of that. That's all right. These are both junk as well, so goodbye. All right, there we go. 4 bits of cable, 4 signals to be routed. Let's strip these back. So I've just stripped and tinned all of these, and you'll notice that the ground wire has a little bit more exposed on it. What I'm actually going to do is cut those back. So they're basically flush with the start of the actual signal wire. The reason for that is because you'll notice all of these ones on the outside are all ground pads, and then we've got our signal pads further in. So if we tin all these up, and now what we can do is first solder the ground connection, and then the signal wire should reach over to the actual pad for that particular signal. Just like that. Rinse and repeat. All right, that's all of those connected. Now before we solder it to the DIN connector, we actually need to drill a hole first and install this into the case. So I think our best bet, because of that post, is probably to put it over here, which happens to be just near where the old RF cable came out. So something around there seems pretty good. I'm just going to drill a little pilot hole around there, I think. Yeah, it looks pretty centered. Good enough. This drill bit is very blunt. All right, that'll do to start. Now, how big is this thing? It's about 14.6, so 15. Do I have a step bit that does 15? I can go up to 16. Drilling, drilling, drilling. Which one's 16? There we go, beautiful. Of course, we need a couple of holes for some screws. In fact, I might steal the little tiny drill bit that I usually use to clean out the desoldering gun and make a couple of holes with that. It'll be fine. There we go, like it was there from factory, right? So looking at this from the solder side, the top left pin is Luma, top right pin is audio, bottom left pin is composite, which means bottom right pin is chroma, and the center pin at the bottom is ground. If you stick with that, you'll at least have a somewhat standard pin out. So this time I've exposed about 2 or 3 times as much of the ground connector, because these are all going to get tied together and go to that single ground pin on the DIN connector, and it's only the signal wires that we need to connect up to the right pins. All right, there we go. All our wires are soldered. So it goes Luma, composite, ground, chroma, and audio. Now, if you want to put this shield back on, probably the easiest option is just to cut a little bit out of this corner. Personally, I'm not going to be using this, so I don't really care. All right, with that done, we can flip this back over, making sure all our wires are not getting trapped anywhere. And if you really wanted to, you could still plug in the RF output and obviously still route it through the bottom of the case here. But I'm not too concerned about that. All right, there we go. No ugly cables hanging out, and unless you go looking around the back, you wouldn't even know it's been modded. Alright, to test this out I'm going to be using the RetroTink 5X. I'd normally prefer to use a CRT, but the Commodore monitors back there are all PAL models, and this is still an NTSC system, so it's not going to work with them. And at least with the 5X we can get a direct capture so you can see how good or potentially how bad the image looks. Keep in mind, you know, this is a console from the late 70s, so it's not going to look perfect like RGB quality, but I think it should look pretty damn good, all things considered. Now, one of the good things about the 5X is you don't necessarily have to use the S-Video connector for S-Video. You can also use the blue and green RCAs for Chroma and Luma. So I'm just going to use a regular RCA cable. Obviously we'll put Chroma on red, Luma on white, and obviously you'd normally use yellow for a composite, but we're going to go for audio on yellow instead. So audio. Unfortunately the RetroTink doesn't have a mono audio setting. That would be kind of handy. You could always use a Y splitter for dual channel mono. Let's change this to S-Video green and blue. Power on. We've got video. Yeah, there it is. First things first, I'm just going to load up this color bar generator. This is a test pattern generator, but yeah, as you can see, they all look pretty damn good. Now, this does also have a little feature to adjust the color adjustment trim pot, this big one here. Unfortunately, on the 6 switcher, I think you have to actually open the case to make that adjustment. So probably jump the gun a little bit, putting all the screws back in this thing. Right, let's load up that program again. Yeah, it's probably a good idea to do the color adjustment before you put all the screws back in the case. So one of these holes actually leads to a little trim pot. And there goes the cover off that. So yeah, if I turn this little trim pot, you can see the bottom half of the screen changes color. Basically what you want to do is get the top and bottom half to match as closely as possible. So it was pretty much already spot on, but I just wanted to demonstrate what this thing does. Of course, if you can't get a copy of this test pattern program, load up your favorite game and just, you know, twiddle this thing until the colors look right to your eyes. I mean, nobody can really tell you what the correct colors are, apart from this test program. That's good enough. Right, enough of that boring test pattern stuff. Let's play some games. So that's how S-video is looking. Let's switch over to composite, see how that looks. So that's how NTSC is looking. I think you'll agree that it looks pretty damn good. And one of the cameras just shut off. I'm gonna do the same for the other consoles, install these DIN connectors, and we'll come back and have a look at how PAL looks. Right, the wiring is complete. So with the 4-switcher, I decided to put the DIN connector on the top half of the shell, basically in line with all the other jacks. And for the Junior, I actually went with removing the original RF connector, which was up the back of the case here, and instead putting the DIN connector there because I don't plan on using RF anytime soon. I did have to widen the hole a little bit to fit the DIN connector, both on the bottom and top half of the shell. But I think it looks pretty neat, and the only downside is, it's silver and not black, but I can live with that. I will say that I also tested using just a single ground connection, so basically a 5-core cable, so 4 wires to carry the signals, and then just a single ground wire, and that did result in a little bit of interference. So analog video is pretty sensitive to noise, so I'd highly recommend using all 4 ground pads and obviously have separate signal and ground wires. So before I put the cases back on, let's give these a test. We might have to adjust the color trim pots on these. I guess we're about to find out. So we'll start off with the Junior, and it's currently hooked up via S-video. Everything's looking pretty good so far. You'll notice that this test pattern generator, the board is just grey, and that is because it doesn't work properly on PAL models. So we'll have to use something else to actually make sure the colours are looking correct. Of course, a game that I'm very familiar with by now is Pitfall, so let's load that up. And yeah, I'd say that already looks pretty good. Of course, we can mess around with this color trim pot, and if we turn it one way or the other, yeah, I don't think that's right. Something around there seems about right. Let's quickly swap over to composite. And there we go, that's how it's looking with composite. Better have a little play while we're here. Of course, it is slower than the NTSC version. That's just because of PAL slowdown and lazy developers not porting their games to PAL correctly. Not that I would really complain, because I still love this game. Loved this game. Let's check out the 4-switcher. Just kind of rest that there. Okay, yeah, we're still on composite, so it doesn't look as good as S video, but at least it's good enough to adjust these colors. It does look like they're going to be wrong. Oh yeah, that ain't right. Looks like the trim pot is in this hole. Oh yeah. Yeah, something around there seems pretty good. Let's just make sure I didn't do anything silly with S video. Swap that over to there. Swap this over to here. Oh yeah, that looks good. One more time. Cool, so that's what it looks like with a direct capture. Let's have a look at what it looks like on a CRT. All right, here we are with the good old 1084 and of course a bit more pitfall. This is what it looks like via S video. With composite, it looks pretty much the same. It's very hard to tell the difference on a CRT. In fact, let's just swap over just for shits and giggles. And yeah, that's what composite looks like. Especially on camera, it's probably going to look exactly the same. All right, that's going to be it for this one. I'm just going to turn this off for a moment because it's making a horrible high-pitched whine. Hopefully the flyback in this thing is not dying. Obviously, these will be available on the new Electron store, and I want to give a massive shout out and thank you to my patrons who've been supporting me while I've been developing this thing. As a little bonus in return, they get discounts on everything on the Electron store. So if you're interested in becoming a patron and supporting future developments like this, please consider joining up. Obviously, you'll also get ad-free early access to all these YouTube videos. But yeah, that's going to be it for this one. Thank you all for watching, and I will catch you in the next one. Bye. I hope this thing's not dying. And now it sounds fine. I need to get my pitfall on. This is a funny angle. It's because I was on an angle. That was a bad idea. We'll finish you one day. Get out of here.